Okay, new unit, polar coordinates. I noticed I'm a little bit behind on these videos. Was meaning to get these out a week before the quiz on the unit was due, so I'm going to do my best to get as many of these videos out as I can today for this unit because I know that the quiz is due in 1 week. Okay. You'll see I already put the practice problems on the Canvas site. I'm going to put those practice problems in the description below this video also, so they're there for you. But if you go to the Canvas site, you'll have links to the worked out solutions to those practice problems as well. So if you haven't checked that out yet, definitely do so as soon as you can. Okay, so what are polar coordinates? Polar coordinates are a new way to define locations of points in space. And you might think, why do we need a new way, a new set of coordinates? Well, there are very many uses for them in different applications, especially in physics. It's nice to have polar coordinates for different things. I'll show you a little bit of that here in this video. Okay, so let's suppose that you are at point A. No, sorry, you are at the origin and you want to go to point A. And I am going to give you directions for how to get there. Well, if we went with the old Cartesian system, the Cartesian coordinates, x and y coordinates, I could tell you, okay, well, A is at the location 5, 5. 5 in the x direction and 5 in the y direction. That would be using regular, what we call Cartesian or rectangular coordinates. Okay, so in that case, if you were right here, you would walk 5 in the x direction, and then you would walk 5 in the y direction. Okay. The problem with this is it's not the only way to get to point A, and it's not the fastest way to get to point A. Okay? What would be a better way, a more efficient way to direct you standing at the origin to get to point A? Well, rather than walking 5 in the X and 5 in the Y, why not just walk straight there? Okay? I could tell you, instead of walking 5 in the X direction, I could tell you to walk a certain distance in this direction, and you would end up at point A right away. But first I would have to tell you which direction to face before you start walking, and then I would have to tell you how far to walk to get to point A. Okay, so first I would have to tell you this angle, right? The angle from the x-axis, that's the standard 0 position of the x-axis, right? And then I would have to tell you how far to walk. How far is this? Well, if we look at our right triangle here, we know this is a special right triangle. It's a 45, 45, 90. We know this is going to be 5 root 2. And we also know that theta, as I just said, is going to be 45 degrees, or how many radians? Pi over 4 radians. Okay, so here's the Cartesian coordinates. The polar coordinates, that is the second set of directions where I just tell you to walk straight to point A along that hypotenuse. The first thing I tell you is r, which is the distance that you have to walk. In this case, it's 5 root 2. And the second coordinate is the angle that I tell you to walk, right? The angle from 0. So that would either be in radians, pi over 4, or in degrees, 45. Normally you'll see it in radians, especially in this class. Okay? So let's just reiterate the same stuff, but more generally. Okay, so here I've just written two different versions, comparing the two coordinate systems side by side. Okay, so in the Cartesian coordinate system, or rectangular, it's also called rectangular. Okay, you're given an x and a y coordinate. This is what we're familiar with. You've been doing this since pre-algebra. Okay, polar coordinates is the new stuff, and I'll show you a little bit about how it's useful here in a minute. But in polar coordinates, the first coordinate is not the x, it's the r, which is that distance from the origin that the point is. Okay, and then the second coordinate is theta, which is the angle or the orientation at which r exists. Okay, so let's get a little bit of practice plotting points in polar form. And in order to do so, it's very helpful to have polar graph paper. Okay, you aren't going to need polar graph paper for this lesson, but I am going to have I'm putting a link where you can download a PDF of this in that Canvas page where I put the practice and YouTube link in Canvas. I'll put a download for this unit and for the next unit because it'll be more useful for the next unit. Okay, so let's just plot all these points on this set of polar graph paper. Well, we still have our x and our y axis, But notice instead of having grid lines vertically and horizontally in the x and y direction, we have grid lines for each r value, right? For each whole number r value. If r is 1, we are on a circle 1 unit away from the center. If r is 2, we'll be on the circle 2 units away from the center. And then I have grid lines for a bunch of different angles of theta, right? 0 degrees, 90 degrees, 45 degrees, and I've got my 30 degree and my 60 degree lines there as well. Let's label some of those. I know this is 0. I know this is 90 or pi over 2. We'll label these in radians. I know over here I've got pi. Okay. I know that halfway to pi over 2 is going to be pi over 4. And it looks like my pi over 2 has been divided evenly into 1, 2, 3, 4, 5, 6 slots. So I know that each of these is 15 degrees, 90 divided by 6. So 2 of them would be 30 degrees, which I know is pi over 6. And then 2 of those I know is going to be pi over 3. So those are the common angles that we have on the angles on the unit circle that we've memorized. Okay, this one is pi over 12, and that one is 5 pi over 12. Okay, but we won't label those for the sake of cleanliness here. Let's graph the point for pi over 3. Okay, remember the first coordinate tells us the r value, how far from the origin we are. So we know that we're 1, 2, 3, 4 away from the origin. So we're somewhere on this circle here that has a radius of 4. Okay, so 1, 2, 3, 4 away, but at what angle, what orientation am I on? Pi over 3. Okay, so 4 away, I go to pi over 3 right there. So I'm 4 units away from the origin, and I'm oriented in the pi over 3 direction, so that is point A. Okay, that's how you graph a point in polar coordinates. We could also graph that point in Cartesian coordinates. We'd have to convert to Cartesian coordinates, and we'll show that in 2 videos from now, or 1 video from now. Not in the next video, I think the next one after that. Okay, so let's graph point B, 3 units away, 1, 2, 3. So I know I'm somewhere on this circle that has a radius of 3, and 5 pi over 4 radians from 0. So 5 pi over 4, well there's pi over 4, there's 2 pi over 4, there's 3 pi over 4, there's 4 pi over 4, here's 5 pi over 4. Okay, so I'm on this line, 5 pi over 4, and I need to be 3 units away from the origin. So right here is point B. Okay, I hope that makes sense. Point C, what do we do if we have a negative r value? Good question. That's why I put this in here to hopefully address that. I always like to start with the direction and then I do the radius. So let's go to pi over 4. So we know we're on this line. But rather than traveling towards pi over 4 by 3, I'm going to travel towards pi over 4 in the negative direction. Okay, so I'm oriented pi over 4, but then my radius is negative, so I go in the opposite direction to achieve that negative 3 distance. Okay, hope that makes sense. So pi over 4, I'm looking this direction, but I turn around and go the opposite direction 3 units. So instead of going along pi over 4, I'm actually going along 5 pi over 4, 1, 2, 3. So yes, we actually end up in the same location as B. So not only is that the location for B, that's also the location for C. Yes, you can have 2 different coordinates for a point in polar coordinates, in the polar grid here. You can actually have infinitely many different coordinates for a single point, right? Because not only is this pi over 4, this is also 2 pi plus pi over 4, right? Or any coterminal version of that angle, right? And then I could do the pi over 4 plus 180 degrees and then have a negative radius to get over there. There's all sorts of, there's infinitely many ways to produce that point, and we'll get to that in the next video. Okay, last one, D, is at 5, negative pi over 6. I just threw this in here so that you remember how to achieve a negative value for theta. You just go clockwise, right? So here's 0, negative pi over 6 is going to be right there. And we're going to be at a distance of 5 away from the origin. 1, 2, 3, 4, 5. So there is point D. Okay. Okay, last thing I'll show you. This video's gone on so long already. Maybe I should do this in another video. What the heck, let's just do it. I'm just going to show you why polar form is nice for certain graphs. Okay, let's graph x equals 6. Just the good old equation x equals 6. Well, if you remember, this is a vertical line. Over here on the x-axis, if I find 6 on the x-axis, right there, this is the line x equals 6. Okay. Why is that the line x equals 6? Because every point on this line solves that equation, right? Every point on this line has an x coordinate of 6. And so that solves that equation, right? So this point right here, 1, 2, 3, 4, that is the point 6, 6. Does it have an x that's equal to 6? Yes. This point right here is 6, negative 2. Does it have an x coordinate of 6? Yes. So all these points on this line solve the equation x equals 6. Well, what points would solve the equation r equals 3? Okay. Well, that would be all the points that are 3 away from the origin. Can you think what that would look like? Doesn't take long before you realize that's a circle. This point is 3 away from the origin, that point is 3 away, that point is 3 away, and that point is 3 away. All these points are 3 away from the origin. So this is the equation for r equals 6. Okay. Remember how to graph a circle in Cartesian? Wouldn't that be x squared plus y squared equals, sorry, not r equals 6, r equals 3. That was silly. X squared plus y squared equals 9. That's how you would graph that same circle with Cartesian variables. But now it's as simple as just saying, oh, r equals 3. We can graph that. Okay. How about theta equals 3 pi over 4? What's that going to look like? What points will all have the orientation of 3 pi over 4 from 0? Well, here's 0. 3 pi over 4 is this 135 degree angle, right? All the points, in fact, on this line that I just drew are going to have a theta value of 3 pi over 4. Okay, so you can graph lines in polar coordinates just by identifying what the value for theta is, and then all the points on this line have that value for theta, 3 pi over 4. This side has the positive r values. This side over here would have negative r values. Okay, so that's a little bit about why polar coordinates are useful. It gives us an easier way sometimes to graph things like circles and lines through the origin and a lot of other things. We'll get to graphing polar equations later on. Okay, that's enough for this video. I'll see you guys in the next one where we learn more about polar coordinates. Bye.